There we go. So, like I said before, we're breaking it up into 3 parts. Breaking this up into 3 parts, we've got Unit 2A, which is just going to be focusing on the expressions. So Unit 2B is going to focus on our equations. Unit 2C is going to focus on those inequalities. So we're talking about our expressions first. So our learning target is that we can identify parts of an expression and simplify expressions by combining like terms and using the distributive property. So we're probably only going to get through the first page, your first page front and back today. We'll do the distributive property tomorrow because I want to break it up into little small sections for you guys, so that way we're not testing quite so quickly, but you're probably going to take a test on this not tomorrow, next week Friday, or the following week after that on like a Tuesday. I don't like to test Mondays most of the time. Yeah. All right, so the expressions mean that you, especially if you're talking about an algebraic expression, you have got parts to it which are a variable. You might have you do have a coefficient if you have a variable. You might have a constant, but there's not going to be any equal signs. Equal signs indicate an equation. We're talking about expressions. Expressions create equations, but we are not focusing on equations yet. So we're just focusing on those expressions. Now, each expression has what we call terms. When we split these terms up, and I'm going to go ahead and highlight the word terms in orange. So what a term is, it's a number, or it's a variable, or it's a product or quotient of numbers and variables, and they are typically separated by addition and subtraction signs. Okay, then we have our term coefficient. I'm going to go ahead and highlight coefficient in pink. So my coefficient is the number factor of a multiplication term involving a variable. So here's what I mean. If I'm looking up here in my expression, this number right here, 6, that's my coefficient. The biggest mistake that people make all the time is when I say, hey, tell me my coefficient, they say 6x. But 6x is not a coefficient. The 6 is the only part that's considered to be the coefficient. 6x is actually called a term. So this is your first term. Oh, and I'm just realizing that orange is really crappy, isn't it? Okay, so let's do a better orange. Okay, this is my first term. Okay, this plus 2, this is my second term. Done? Awesome. Thank you. Okay, so like I said, your terms are just numbers, or they might be just the variables, or a combination of products and quotients for numbers and variables, and they are separated by addition and subtraction signs. So 6x is my first term, then I've got a plus sign. That plus sign belongs to the 2, okay, because I'm saying I'm adding a 2. So what I'm adding is the 2. That plus sign belongs to the 2, just like a minus sign belongs to whatever you're subtracting. Okay, those signs are important because when you separate your terms, those signs will now become your positive and negative signs. They will indicate whether that term is a positive or if that term is a negative. All right, we've got our variable. And variables I'm going to go ahead and highlight in my blue. That is your unknown value, and it is typically indicated as a letter. Most popular letter that we tend to use is going to be our x. But of course, we can use several different kinds of variables. We can use y. We can typically use like r. Some of the variables that we tend to try and not use, we don't usually use o. Because why? Why do you think we don't use o? It looks like a 0. Do you have a question, honey? Is that blue not working? Let me see. Go on up to those boxes over there and just steal a blue out of that and leave it for yourself. All right. Yeah, because the O tends to look like a 0. We sometimes don't use T. I mean, there's very few occasions that they'll use the letter T, but a lot of times we try to stay away from T. Why do you think we don't want to use T? Looks like a plus sign. Okay. So there are certain letters that we try and stay away from. Yeah. If it's not working, throw it. All right, and then we've got what we call our constant. And our constant, I'm going to go ahead and highlight in green. And again, I'm going to highlight the sign that is in front of it as well. The reason I want to highlight the sign in front of it is so that I know I am indicating that that is a positive 2. So this is going to be my constant. So our constant is the number that is added or subtracted in your expressions. So if you've got a value that's being added or subtracted in your expressions, we call that our constant. So just to reiterate one more time, our terms are separated out by our plus and minus signs. So you have first term, plus a second term, maybe minus a third term, maybe minus a fourth term. You know, we're going to be having those plus and minuses separating our terms out. Our coefficients are basically attached at the hip. Think co. If you coexist or you are codependent, you are attached to something. Okay, when you are a codependent, that means that you are depending on somebody, right? You are codependent to your parent. That means you depend, you're attached to your parent. Coefficient, you are attached to your variable. Your variable is always your letter. It varies, it changes, it's unknown. Your constant is a thing that does not change. Okay, you are always adding the 2, or you are always subtracting a 7, or whatever it might be. But it is always just a plain number. It's constant. Okay, there's no variation to it. All right, so let's take a look here. A couple of examples down here. What I want you guys to do is, based off of the examples given, I want you to identify what are the terms, the coefficients, the variables, and the constants for each of the 2 expressions that I've provided for you. Do not forget your sign. Okay, if there is a minus sign, that minus, so like here, minus 4, that indicates that that is a negative 4 when you are separating it out as a term. So please be mindful of that. Go ahead and try it on your own. Use pencil. You can always highlight later in your colors if you want to, but use pencil to practice. Okay, so taking a look here, my terms. My first term is the 8x. My second term is a negative 4. Okay, that minus sign becomes like a negative sign. It's attached itself to the 4. Okay, coefficients. What are my coefficients, guys? 8. Just the 8. 8 is the only thing that is considered to be a coefficient. I can even highlight that 8. Okay, that's the only thing that is considered to be a coefficient. Let me zoom in so you guys can see it a little bit easier. Okay, what are the variables going to be? Cole? X. Okay, X is going to be the variable. That is the only variable that we see here. And then the constant. What's my constant? Negative 4. Good catch. Negative 4. Okay, so that negative is going to attach itself to the 4. Okay, and then again, this is my first term, this is my second term. Okay, now let's take a look at number 2. My terms, let's start from the very beginning. What's the first term? 3. Go ahead, you guys can shout it out. We've got 3, that's our first term. What's our second term? Negative 2x. What's our third term? Positive 9. I can just put 9. Fourth term, 7y. It's a positive 7y. And then negative 13. That's our last term. Okay, so there's our different terms. Our coefficients. What are the coefficients going to be? Negative 2 and a positive 7. Remember, don't put x. Don't say negative 2x. X is not a coefficient. X is the variable. The coefficient is what's in front of the variable. So negative 2 is the coefficient. 7, a positive 7, is also a coefficient. So what were the variables then? X and y, right? We had the x and the y. Those are our variables. And then our constants, what are our constants here? 3, positive 9, and then what did you say? Negative 13. Mason, shut up. It was both of them. All right. Any questions about this? Again, it's vital that you understand the positive and negative when it goes and attaches itself to a variable or a constant. Because when we get to the next page on the back, we're using those positives and minuses to be able to indicate how to combine like terms. So when we're talking about like terms means that they have something in common that they can combine it together. So the best way that I would describe it, if you are trying to combine colored toys together, you would say, okay, well, these are all blue toys, these are all green toys, these are all purple toys. Well, I can't stick this yellow toy with the green toys because they're not in common. They don't have something in common. Okay? So you have to focus on what it is that they have in common. So you can combine constants together. You can combine same variables together. But the variables also have to be to the same power. So x and x squared are not the same. Just the same as x and y are not the same. So they have to have same powers. Your constants and your coefficients are going to tell you how much of those that you have. Okay? So for example, with my like terms here, I know that I have several constants. I can combine 7 together, and I can combine negative 8 together. The reason I can combine them together is because they are both constants. So 7 and negative 8 are like terms. Because I'm just going to put BC. They are both constants. So I can say that 7 and negative 8 can be combined together because they are both considered to be constants. I can combine 4x and negative 1/2 x together because they are both written in terms of x. So 4x and negative 1/2 x are like terms. Okay, they are both x. Yes. Yeah, see? Well, see, this one of them's positive, one of them's negative, but they're still like terms. It's not the positive or negatives that are making them like terms. It's the variable that makes them like terms, or the lack of variable. So a constant doesn't have a variable. That's what makes them in common. Okay? They're just numbers. These have an x in common. So that's what makes them alike. Just the same as these ones, the negative 2y and the 0.6y. They're like terms because they both have a y in common. So negative 2y and 0.6y are like terms because they both have that y. Now, again, keep in mind, I want to make sure you guys understand this, so let me go ahead and write this up at the top because this is really important to remember. I'll put it in my little black. X and x squared are not like terms. x and x squared are not considered to be like terms. When you start adding exponents onto your variables, that creates a different value. So like x, let's say x was equal to 5. X squared is not 5, is it? What's x squared? What's 5 squared? 25. So x and x squared are very different things. So if I say I have 3x and I have 2x squared, those are very, very different considerations. You cannot combine those together. All right, so x and x squared, not like terms. Exponents will change your variable. All right, so what we're going to do is we're going to go through these real quickly. We're going to combine these like terms together. When you are combining like terms, you ignore the variable and you focus on the coefficients. So what I mean here, I've got 4x and 3x. I'm going to ignore the coefficient, or sorry, the variable for the time being. I'm just going to focus on the 4 and the 3 and add those together. And at the very end, I'm going to attach my x. So what's 4 plus 3? 7. So 4x plus 3x is 7x. Okay, if we're looking at problem number 2, the only like terms that I happen to have right here, I have 3x and I have a minus 8x that are like terms. My plus 6 does not have a like term. It's all on its lonesome. So we're going to focus on doing 3x minus the 8x, which is what, Caleb? Negative 5x. Don't forget your variable. It's negative 5x. And then this plus 6 has nothing that can get combined with it, so it just stays plus 6. So we have negative 5x plus 6 as our final answer. If we take a look at problem number 3, again, negative 5x plus 6 is our final answer. So if we take a look at problem number 3, again, we're focusing on what our like terms are. We have a negative 2y. Do we have any like terms in common with negative 2y? The 7y, right? We have a 7y. So I'm going to go ahead, I'm going to do negative 2y and a positive 7y. I'm going to highlight in my blue. Do I have any like terms in common with this 4x?
Yes, 2x.
The 2x. I have a positive 4x and a positive 2x. Okay, now, when we are writing our expressions, it is common practice to write in alphabetical order. It is common practice to put them in alphabetical order. So I'm going to focus on writing my x terms first, then my y terms. They won't always be that way, but the majority of the time, your answers are typically in alphabetical order. Okay? Just get used to the practice. So we have a positive 4x, and we are adding a 2x. When we add those together, that's going to give us 6x. Then we have a negative 2y, and we're adding a 7y. When we combine those together, we're going to get a positive 5y. Now, I need to write these together, so which sign should I put in between here? A plus, right? Because I said it was positive 5y, didn't I? If it was a negative 5y, then I would just leave the negative as a subtraction sign instead. So I would say, oh, it's minus 5y. So just be mindful, those signs will become operations eventually when you put them together. So 6x plus 5y is your final result. Taking a look here for problem number 4, starting with our first term, we have the variable n. Do we have any common terms, like terms with the variable n? 9n? Negative 9n. Minus 9n. Remember, that sign belongs with it. Okay, then we have negative 4, which is a constant. Do we have anything in common with the constant? The positive 7, right. Okay, so now we start with our variables first. We're going to have n minus 9n. Now notice this n doesn't have anything written in front of it. So does it have a coefficient? Think again. I want all of you to turn around and look at the back board where it says invisible math. So taking a look over here, every variable has a coefficient. If the variable is written isolated and it does not have anything written there, then what is its invisible coefficient? A 1. Okay? It does not matter. If it is a variable, it has a coefficient. Variables always have coefficients. So if you don't see one written, then that means it has an invisible 1. So always get used to writing a 1 here, just because I know a lot of people look at it and they go, oh, n minus 9n. Well, there's no number in front of it, so it's just negative 9n. It's not. Okay, you have 1n minus 9n. What is 1n minus 9n?
Negative 8.
Negative 8n. You said 8. Negative. So we have negative 8n. All right. Now we've got our constants. Negative 4 plus 7. So negative 4 plus 7 is going to give us what? Positive 3. So I should write my positive sign because I need to put an operation there. So that positive 3 becomes a plus 3. So we get negative 8n plus 3. All right. For problem number 5, starting with our first term is a negative 3x. Do we have anything in common?
Positive 15.
Positive 15. Good. So we have positive 15x. So I'm going to write those down. I've got negative 3x, positive 15x. What do I get when I do negative 3x plus 15x?
Positive 12.
Positive 12x. Don't forget your variables, guys. Okay, then we have negative 9. That's a constant. Do we have a common term with it?
Negative 2.
Negative 2. Okay, so we have negative 9 minus 2. What's negative 9 minus 2?
Negative 7. Negative 11.
Negative 11. Okay, now notice I'm going to write negative 11, so that negative now looks like it's a subtraction sign. So it's right, you're saying minus 11. 12x minus 11 would be our final answer. Okay, our last one. We have 7y.
8y.
Not just 8y. Negative 8y. Okay, we have negative 11x. Positive 11x. And then we have positive 12. Nothing with it, right? Okay, starting in alphabetical order, we're going to start with the negative 11x
0.
plus the 11x, which is going to come out to what?
0x.
0x. So what's 0x, guys?
1.
What's 0 times x?
Oh, 0.
0. So do I have to write it anymore?
No.
No. 0 times x is just going to be 0. So you won't have to write that in your final response. But I'm going to go ahead and continue on with the rest. We start with our variables of y. We have 7y minus 8y. What's 7y minus 8y? Negative 1y. Now, it's a negative 1y. So again, if you look back at the board, top row, purple, the only purple up there at the top row for the invisible math, says every negative variable has a coefficient of negative 1. So if I say negative 1y, I could also just say negative y. I don't have to write the 1. The 1 can be invisible, but I do have to write the negative sign. The negative sign is important. Majority of the time, you're going to see this.
Negative y.
Just negative y. You're not going to see negative 1y. Okay? Now, at the very end, we still had our plus 12, right? Plus 12 is all by its lonesome.
Negative y.
Still has to go up. Yep, negative y plus 12. That will be our final answer. Okay, I want you guys to try, let's see here. Do the, yeah, I think you can do all 6 real quickly. Take about 5 minutes, do these 6 problems on your own real quick. You don't have to do the colors. You do not need to do the colors. Just use your pencil for right now. Okay, taking a look here for problem number 1, you should have gotten 10x plus 9. For number 2, you should have gotten negative 3n plus 9. For number 3, you should have gotten negative 7b plus 2n minus 4. For problem 4, it's negative 10g plus 7h minus 5. For number 5, you have negative 3d minus 3. And then for problem 6, 2b plus 3. Okay, I'm going to leave these up here, but let me quickly show you what it is that you're going to be doing for your assignment.